All right, guys, so this is the second video for 12.4, so if you haven't watched the first, please do that first. Okay, so in this video, we're going to find what matrix we have to multiply this by to get to this. Okay, and we're going to do that by finding the inverse matrix and then, finding the inverse matrix and then using that product, which is the identity matrix, to solve. Okay, so what we need to do is I first need to find the inverse matrix of this. Okay, so to do that, that's what we just did in the previous video. So it's going to be 1 over the determinant. So the determinant is 2 times 4 minus 7 times 1 times, and then I'm going to flip these spots, so 4 and 2. And then I'm going to make both of these the opposite signs, so -7 and -1. Okay, well, this is just 1 over, this is 8 minus 7, which is 1, for -7, -1, and 2. Okay, well, this is just 1, so 1 times all of this. Okay, this is my identity matrix. Okay, so if this is A, this is not my identity matrix, I'm sorry, my inverse matrix. This is my inverse matrix. Okay, so what I'm going to do now is I'm going to go ahead and use this to multiply on both sides of the equation. So that didn't turn out like I wanted it to. Okay, so I can do 4, -7, -1, and 2 times this, which is 2, 7, 1, 4. And then I still have X, this matrix, which is going to equal 4, -7, -1, and 2 times 2, 8, 1, 5. Okay, so all I've done is I've multiplied the inverse matrix on both sides of the equation. Okay, just like I do in normal algebra. Okay, well, what happens then, remember, the inverse times itself, this is going to be the identity matrix. Okay, and then I can multiply this out over here. So 4 times 2 plus -7 times 1, and then -1 times 2 plus 2 times 1, and then back up to the second column here. So 4 times 8 plus -7 times 5, and -1 times 8 plus 2 times 5. All right, so clean this up. So remember, anytime I multiply the identity matrix times something, I end up with just that something. It's like multiplying by 1. So this side is just X equals, okay, well, then I'm going to clean this up here. So this would be 8 minus 7, -2 plus 2. This is 32 minus 35. And this is -8 plus 10. Okay, so if I go a step further, I would get my X matrix equals +1, 0, -3, and a +2. And here then is my answer. Okay, so just to go back of what this represents, okay? Remember, if we go back to our original equation here, if I have 2, 7, 1, 4, okay, and then I have X, which I'll solve for, so if I multiply that by 1, -3, 0, and 2, what I would get is the matrix that I want, 2, 8, 1, 5. So that's kind of what that means. Okay, so using the one we just did it as an example, I want you to go ahead and try to do this one on your own. It's the same concept, so try to do it on your own and then we'll go over it. So pause this, do it, unpause, we'll go over it. All right, so hopefully you've tried to work through this on your own. Okay, so when you get your inverse of A, you should have got 2, 3, -3, -4. Okay, so then when you multiply both sides of the equation by that, okay, what you get on the left is your inverse matrix. That's, sorry, your identity matrix, which is why we found the inverse. And then we would actually have to multiply these two matrices out. Okay, so what you get on the left is X, and once you multiply these out and clean it up, you get 24, 13, -33, and -17, and that should be your final answer. All right, so now we're going to use this same concept, and we're going to apply it to a system of equations to solve. Okay, so first thing we want to do is we want to set up the system AX equals B like we just did. Okay, the matrix A is going to be the coefficient matrix. So it's going to give us the coefficients of the variables. Okay, X is the matrix of variables. Okay, and B is called the matrix of constants because those are just numbers. Okay, so we're going to do that first. Then we're going to find the inverse matrix of A like we just did. Multiply both sides, and then solve. Okay, so this is very, very similar to what we just did. All right, so when I set this up, the first thing I have is my coefficient matrix. So I want the coefficients just like they read here. So like 2 and 5. And then I have a coefficient of 1 and 3. Okay, and then if I multiply that by, this is my variable matrix, so I'm dealing with an X and a Y, so I'm just going to put X and Y. I know when I do that, that equals 3 and 2. Okay, so the first thing that I want to do is I want to find my inverse matrix of A. Okay, so I want to find, if this is my A, I want to find my inverse of A. And remember, I do that by finding the discriminant first, so 1 over 2 times 3 minus 5 times 1. Okay, and then I multiply it by that funky matrix where I flip these two spots, so 3, 2, and then I flip the signs of the other two. So I'm just going to simplify this. So 1 over 6 minus 5 is just 1 over 1, which is 1, times 3, -5, -1, +2, which is simply 3, -5, -1, and +2. Okay, so this here is the inverse of A. Okay, so like just like I did before, if I multiply that on both sides, so -1 and 2, if I multiply that by A, so 2, 5, 1, 3, and then I still have my X and my Y, and then I also want to multiply that on the right, so 3, -5, -1, and +2, and I have 3 and 2. Okay, well, what I get here is my inverse matrix, so 1, 0, 0, 1 times X over Y equals, and then I'm going to kind of work this out over here. So 3 times 3 plus -5 times 2. And then this is a -1 times 3 plus 2 times 2. So if I simplify that, 3 times 3 is 9. So I have 9 minus 10. And then I have a -3 plus. All right, now remember, if I multiply anything by my inverse matrix, it's just itself. So I'm left on the left with just x over y equals, well, this is 9 minus 10 is -1. -3 plus 4 is a +1. So this is my final answer right here. Okay, or this means that x is -1 and y is 1. Okay, that's all that means. All right, I want you to go ahead and try to do B on your own. Okay, so use A as your reference. It's the same thing. So set up your system, set up your constant, set up your coefficient matrix, all that, and then solve using matrices. I know all of you can solve by hand, but I want you to solve using matrices. All right, so here's what you should have gotten. Okay, in a nutshell, you should have gotten x is -25 and y is 16. Okay, so first thing I did is I just labeled this B. Okay, it doesn't matter. You can label it A, C, whatever. And then I found my B inverse, which I probably should have labeled over here, which was right here. Okay, so that's the process. And then I multiplied that B inverse on both sides of the equation. Okay, and then I worked it out. So when I multiplied this, remember the purpose of the inverse is to get the identity matrix. And so we did that. And then I actually physically multiplied these two out. And the identity matrix means that I can multiply anything by itself. I can multiply anything by the identity matrix and it equals itself. So once I multiply what's on the left, I just get x and y. And then if I clean this up, I get -25 and 16. So in other words, x is equal to -25, y is equal to 16.